Today, we discuss about the normal form of a matrix. So let us take the example based on the normal form and the rank of a matrix. The question is, reduce the matrix A, which is equal to 3, 2, 5, 2, 7, 1, 1, 2, 3, 5, 3, 3, 6, 9, 15 to its normal form and hence find its rank. Let us define the following terms first. What is the meaning of normal form? The following forms are called the normal form of the matrix. IR, IR0, IR0, and IR000, where IR is the identity matrix of order R and O is null matrix of suitable order. Then the next definition is rank of a matrix. Rank of a matrix A is the order of highest order non-vanishing, means non-zero minor of it. If the matrix is reduced to its normal form, then the rank of matrix will be equal to the order of IR. So if we have given any matrix and that matrix can be reduced into the form like IR, IR0, IR0, or IR000, then this is called normal form of the given matrix. Now the second point, what is the meaning of rank? If we are able to reduce any matrix to its normal form, then what is the order of identity matrix? Like that, this is IR. So R is called the order of identity matrix. So that value of R is called the rank of the given matrix. So we have to reduce the following matrix to its normal form and also find the rank. So the given matrix is this. Let us consider it is equation number 1. We have the matrix A is equal to 3, 2, 5, 2, 7, 1, 1, 2, 3, 5, 3, 3, 6, 9, 15. So if we want to reduce this matrix to its normal form, what is the procedure? So the procedure is like the first A, we have to see about the A11. So we ask one question, is A111? If we are getting the positive response, we should go to the step number 2. But now here A11 is 3, it is not 1. So we should make it 1. So how to make it 1? For making it 1, we can apply the row operation or column operation. So here, if we interchange row 1 and row 2, then we can make A11 as 1. So that's why we are applying the operation R12. R12 means we are interchanging the position of R1 and R2. So the equivalent matrix is converted into this form. The second row is become first row and the first row become second row. Now, this is the first step. Our first step is we have to make A11 1. The step number 2, with the help of this one, we have to make all below element 0 by using the row operation. So here, if we apply the following two operations in R2, R2 minus 3, 1, 3R1, and in R3, R3 minus 3R1, then the matrix will be converted into this form. So how this will convert it? Let us try to check it. Is it correct or not? So we will first apply R2 minus 3R1. So what is R2? R2 is 3, 2, 5, 2, 7. And we have R1. So R1 should be multiplied by 3. So this will be 3, 3, 6, 9, and 15. So let us subtract it. So minus, 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 and minus. So 3 minus 3 is 0. 2 minus 3 is minus 1. 5 minus 6 is minus 1. 2 minus 9 is minus 7. And 7 minus 15 is minus 8. So we have this second row is converted into this form. After that, let us apply this operation R3 minus 3R1. So we have the third row 3, 3, 6, 9, 15. Now we have to multiply first row by 3. Then this will become 3, 3, 6, 9, and 15. And now if we subtract it, we are getting 0, 0, 0, 0, and 0. So the third row become all 0, 0, 0. So now we have reached the step number 2, or we can say that we can cross the step number 2. The 1 is 1, A11, the step number 1, we have to make A111. Step number 2, with the help of these 1, we have to make these 2 0. Now, let us go to the step number 3. What is step number 3? With the help of these A11, we have to make all the element right side of the matrices or first row to become 0. So for that purpose, we apply the operations. In C2, what is C2 minus C1? It will become 0. C3 minus 2C1, it will become 0. C4 minus 3C1 will become 0. And C5 minus 5C1, then it will become also 0. So we are applying these 4 operations. C2 minus C1. So 1 minus 1 is 0. 1 minus 1 is 0. Minus 1 minus 0 is minus 1. No change. 0 minus 0 is 0. Similarly, 2 minus 2 is 0. And minus 1 minus 0 is minus 1. 0 minus 0 is 0. Similarly, 3 minus 3 is 0. Minus 7 minus 0 is minus 7. So 0 minus 0 is again 0. The last one, 5. This operation we have to apply. 5 minus 5, C1. 5, C5 minus 5, C1. So 5 minus 5 will become 0. Minus 8 minus 0 is minus 8. And 0 minus 0 is 0. So this is the step number 3. So now this is the one complete cycle. So in normal form, we have to first make A111. After making it A111, we have to make the below element 0, and then by using the row operation. And after that, the right side element should be also 0 by using the column operation. Now we have to move to A22. So here we repeat the same above process what we have done in the previous steps. So again, we ask the same question. So is A111? So answer is definitely no, because here A11 is minus 1. So we have to make it minus 1. So how we can do it? So either we can multiply this whole row by minus 1, then it will become plus 1, or we can also do multiply this second column by minus 1, then also it will become plus 1. So let us apply the operation. In R2, R2 is multiplied by minus 1. Then what we have? we have 1 0 0 0, 0 1 1 7 8 and 0 0 0 0. Now, once this A22 become 0 or 1, then using this one, we have to make the below element 0, which is already 0. So no need to apply here the row operation. Let us go to the third step. Using this one, we have to make this 3 0. So for that purpose, we apply C3 minus C2, C4 minus 7, C2 and C5 minus 8C2. Then what we have? We have a matrix 1 0 0 0 0, 0 1 0 0 0 and 0 0 0 0 and 0. So this can be written as I2 0 0. So now we can do like this. This is the first matrix which is identity matrix of order 2. So it is represented by I2. This is zero matrix. This is zero matrix of order 1 by 2. This is zero matrix of order 2 by 3. And this is zero matrix of order 1 by 3. So this is called normal form of the given matrix. Now, this is the answer of the first question, means we have given the matrices. This matrix is reduced into the form of normal form. Now the second question comes that what is the rank of the matrix? So rank of the matrix is equal to the order of identity matrix. So this is only when we have reduced any matrix to its normal form. So what is the rank is denoted by row of A. And what is the order of identity matrix? Clearly here it is 2. So the rank of the matrix is 2. Thank you.